Now the next bit I think will be more familiar territory. So the other kind of common single variable that we get to look at in exploratory analysis is categorical variables, and you're relatively limited in what you can actually do with single categorical variables. So the most common thing you do is some kind of bar charts. So I've got a little data set here which is about pizza prices in India, and I'm not sure. It's supposedly real data. I'm not sure how realistic it is. It's I think it's about 6 years since I bought a pizza, and in fact I didn't. It was 6 years since I travelled with someone who ate pizza in India, and I can't remember what they cost because he used to pay for them. Okay, so anyway, this is a table where you've got a quantitative variable which is the price, and you've got a variable which is the diameter of the pizza, which that's an interesting one. Is it quantitative, or is it ordered categorical? That's worth thinking about. And then there's some straightforward categorical variables like the type of topping and the variant. So I'm going to just look at the pizza topping. This data set was actually I got this off Kaggle, which is a site that runs data, artificial intelligence data, machine learning type of competitions. And the purpose of the data set was for people to practice predicting the price from the other variables. But that's not what we're doing here. So this would just be an exploratory bit of data analysis. And essentially what you would do with something like, with a categorical variable like the pizza toppings, is you would tabulate them and check for missing data. So there we are, that's the tabulation. So in this list there are 29 pizzas with chicken topping, 22 with mushrooms, right down to only one with onion topping. And there's no missing data. Now the most familiar visualization for this kind of data is the pie chart. And we don't, it tends not to be recommended for exploratory data analysis. I'll have a little bit more to say about this when we cover visualization for presentation graphics later in the course. But basically there has been a kind of holy war fought over the pie chart for about 100 years. These days, what you typically will find if you do a statistics course taught by a statistician is they will threaten you with dire consequences if you ever use a pie chart. They don't like them, and there's a whole story behind that. But basically, what it boils down to really is that there is experimental research that shows that humans are not very good at interpreting areas and angles, or particularly angles. And so if you had to read the numbers off that pie chart from the angles, you probably wouldn't do a great job at it. That's the key idea. So I'm not going to worry about that for now. We can talk about pie charts later on in the course. So common alternative is this thing here called a stacked bar chart. So what happens here is the proportion, or the frequency here. I could have done this as percentages rather than frequency, but and frequency, remember, is just a number of things. In a chart like this, the frequency or the proportion is just represented by the length. So chicken there, the brown one at the end, that has the longest section. and poor old Onions down here has the shortest. And you can look at that chart and you can get, it gives you some idea of the relative proportion of each type of pizza topping. That's what it does. These kinds of charts, they can be useful. Labeling them is a bit hard, so it's commonly done by coloring them or shading them. The problem you get problems. I'll make this point now, but we'll talk about it more in visualization. You get problems with colors and shading in a couple of ways. One is if the document in which the chart appears is, say, printed in black and white, or printed in black and white and then faxed somewhere, or but also if it's projected. You have to be, even today, today the projectors are much better than they used to be, but you can still get situations where you're projecting a presentation and you discover to your horror that the colors are all wrong. So that can be a problem. And then the other issue you can face is color blindness. So color blindness is how common it is depends on gender and ethnicity. It's fairly common in white Anglo-Saxon men like me. I'm not, as far as I know, colorblind, but I did once give a presentation, quite a long presentation of slides to the CEO of an organization I did a consulting job for, and I had chosen a color scheme which was about as bad as it could possibly be for a person with the most common form of color blindness. And this guy was colorblind, and he rather politely, I have to say, pointed this out to me, so I've carefully avoided making that mistake ever again. This set of colors here is supposed to kind of make sense for, or at least be distinguishable for people with the more common kinds of color blindness, but there are many kinds, most of them fairly rare. So another way of doing this is you just use a standard bar chart. I like to use the horizontal version like this because it's compact on a screen, it's compact in a printed report, and it's pretty straightforward to read. So both of those two are just pretty standard ways of representing the proportions of a categorical variable. And you can look at that, and the sort of things you might look for is sometimes when you're doing exploratory analysis, you think, well, maybe what we should do in future is combine some of these smaller categories or something. I don't know, you might think, well, if it turns out that a meat pizza is always beef, for example, you might combine beef and meat and things like that. But that's essentially the idea. If you're looking to do further, more complicated analyses, sometimes it's important to know whether some of the proportions are very small, because that can that means you might change the way that you do things. I'll show you one more chart. So this is called a dot chart, and this is a favorite of statisticians. Again, it works like a bar chart. It's a horizontal, in this case, presentation. It just turns out, again, there's some research to support this, that a dot chart is even easier than a bar chart like this for people to make accurate visual comparisons. That this is actually easier to read than that. And the reason is that basically the bars themselves become a kind of distraction, because what you're really interested in is the endpoints of the bars, sort of the length of them and the endpoints. So dot charts are, you'll impress anyone who's a statistician if you use dot charts. I don't actually know if you can create them in Excel. Look, one thing I'll say about Excel is, I've spent years and years and years using Excel. They did, for example, they only introduced box plots just a few years ago, in spite of people asking Microsoft to do it for decades. And before that, so for years, if I wanted to do a box plot in Excel, it was this complicated process of you'd sort of start with a bar chart, and then you'd have to remove bits and add bits and fiddle with it, and it was sort of a 10 or 15 minute procedure to create a box chart. Dot charts might be the same, I'm not sure. But I'll also say with Excel, you can get very good statistical packages that you can add to Excel, but they cost money. You've got to pay for them. Okay, the next categorical one. So this is ordered categorical data, and I'm only going to talk about one very common type, and that is data that comes from what we call a Likert agreement scale. So this is a kind of question that is very commonly used in surveys. It's used a lot in those psychological questionnaires that are used to decide whether you're satisfied with your job or intending to leave it, or things like that. Whether you're an introvert or an extrovert, or and so on. So what you get is a series of statements followed by, you have to choose strongly agree, disagree, neither agree nor disagree, agree, and strongly agree. That's the most common format. That's the 5.1. There's a 3.1, there's a 7.1, and then there are also even numbered ones, but that's by far the most common version of it. So these are, there's two schools of thought about the data that comes out of these questions. So one school of thought is these are ordered categorical data. Okay, so strongly agree is a category, disagree is a category, and so on, but it's ordered. So strongly agree is higher, if you like, than agree, and that's higher than neither agree nor disagree, and that's higher than disagree, and so on. This is a little bit of a controversial area, and I've done a fair bit of testing of data over the years that's come from these kinds of questionnaires. I can tell you from my experience that sometimes that's true and sometimes it's not. What you're generally doing with these questions is you're trying to measure a latent construct. You might remember I mentioned that the other week. So these are the kinds of questions that are fairly common in the surveys. So a lot of organisations do these things they call staff surveys or staff climate surveys, things like that. They're basically trying to work out whether the employees are happy and motivated, and whether they're intending to leave or stay, and how they feel about their supervisors, and so on. So each question is trying to measure, or the term that's often used is tap into a latent construct. So these three might be the sorts of questions that are trying to measure whether an employee is comfortable with the organisation's values, whether there's a good fit or alignment. Okay, that's a latent construct. And so what you actually get is data that where, in the end, the way it will typically come out is it'll come out as numbers something like this. Okay, you'll get a spreadsheet probably out of the survey software, and it will either have as the data, it'll either have these names, or it will have maybe a set of numbers. And the assumption, some people assume that these numbers are ranked, that they're ordinal, that they're ordered categorical data. Some people won't make that assumption without checking it. So I tend to fall into that category, only because I've seen cases where it's not true. And then some people will go further and actually assume that this is interval level data, and that's definitely not always the case. So we have to be a little careful with these kinds of numbers. With the 5-point Likert, the big problem is this neither agree nor disagree. So what it's supposed to be is it's supposed to be a level of the latent construct being measured, which is somewhere between disagree and agree. But the problem is that it gets selected by people who don't understand the question, don't want to answer the question, or are just lazy and want to flick through the questionnaire. So essentially that middle one tends to, not always, but often, it basically creates a bunch of noise in the data. So the advice I give people, if you're designing a questionnaire, don't put it there. Just force a choice. Now, but I know plenty of academics who will disagree with that. There you are. So just be careful with that. Now, this is a reasonable way of representing the results of a survey like this. So this again is showing, these are stacked bar charts. So I've used frequency here. In a presentation to an audience, it might be better to use percentage to use proportions. That might be make more sense to them, but the chart would actually look the same. I've used colours there, so these are supposed to be colourblind friendly colours, but I've used what's called a divergent colour scale, which kind of ranges from to me that's a kind of pinky magenta colour to pink to white, and then a light green and a dark green, and apparently that works. It works reasonably well if you print it out in black and white. Notice that I've recorded non-answers there. It's pretty common with questionnaires and surveys to get non-answers. People just skip a question either deliberately or by mistake. And as I've said a few times in the course, you actually have to know about that missing data because it can create problems for later analysis. Let me also just say this, I'm sure there's stuff about whether these things are, categorical or ordered categorical or interval or whatever is probably still a bit confusing. It's something we're going to get to later, but I'm just drawing attention to it now because it's quite important and it comes up all the time in management situations. We're often dealing with questionnaire data that is trying to measure some kind of latent construct, and we need to take care with the quality of it.